We're going to talk again about the microservices trend that we're experiencing, and now we're going to focus on how to test it. So please welcome Katherine.
Thank you very much. So hello everyone. Today I'm going to be talking about testing microservices. I'm really pleased that there's so many of you here today clearly excited about testing, because I really think it's an area that can be kind of forgotten or left until later, and I think it's really important. So first, a quick introduction. My name's Katherine Stanley, or I'm generally known as Kate, and I'm a software engineer working at IBM on WebSphere application server Liberty. I've been there for about 18 months, and so far I'm really, really enjoying it. And it's allowed me to come and do exciting things like coming to speak to you today. There's a link there to GitHub, where I have on my GitHub account, and Twitter as well. So I've been tweeting about the things I've been up to at JFocus. So far, I've really enjoyed it. So on to the agenda for this talk. I'm first going to cover some background about why I'm here today and why I'm going to talk about testing microservices and kind of my experiences that I've had so far to explain to you why I've kind of formed the views that I'm going to share with you today. I'm then going to go on to talk about what are microservices. There's been quite a lot of talks about microservices at this conference, so hopefully most of you have got the basics down, but I'm just going to do a couple of slides just as a refresh in case some of you have been avoiding the microservices talks or want to refresh. I'm then going to introduce an example application architecture. So throughout this talk, I'm going to use an example application as kind of a framework to discuss testing microservices and highlight why you need the different testing strategies. So I'll introduce that and then move on to talking about the different testing strategies. And then the final piece will be covering evolving a monolithic application into a microservice application. And although all of the testing strategies I'm going to cover apply to any microservice application, there are perhaps some extra things that you need to consider when you're looking at specifically evolving your monolithic application, and some sort of testing considerations as you go through that journey. And then a conclusion. So let me introduce you to the Liberty Starter, which is the example application that I'm going to use. It's a tool that I've been working on with my team back in the UK, and it's a tool just to get people started with writing Java applications, and more specifically, writing Java EE applications on Liberty. We found that, particularly when you're moving to microservices, you have to write a lot of the build code and configuration before you can start writing your actual application, like the meat of it. So the Liberty Starter just gets you to the point of writing your application code much more quickly. There's a set of technology options to choose from, and when you select them, you then download a zip file which has an application sort of pre-configured inside that you can build and run using Maven, and it will compile your code, run some tests, and start your application. And it also has configurations specific to the technologies that you've just selected. So if you select REST or you select Spring Boot with Spring MVC, it will put in the Maven dependencies that you need. So you don't have to go and edit your Maven file and add all your dependencies. You can just get started. And the reason that I'm using this application is because we started building it to help people, and we thought, great, we'll just build it, and we built it as a monolithic application. But then once we kind of got the beginning of it out there, people started saying, well, this is really cool, we want to add new technologies. And we thought, actually, if we keep it within our team, and it's just our team that owns it, we're going to get to a point where there's so many different technology types that we're having to go talk to the people who know about Spring Boot or talk to the people who know about REST, and then come back and us manage this massive monolith. So we thought actually moving to microservices would help us manage the application better. So we decided to have a piece of the application, a service for us to own, and then have technology pieces for other teams to own. So my talk today is kind of going to cover the things we found as we've moved to microservices, the things we found now that we're kind of there and looking at what testing we should be doing to make sure we're happy with our application, And I'm going to kind of combine that with some of the things that are already out there in terms of information about testing microservices. Although, given the amount of information we've had today about microservices, there's actually, in comparison, not too much out there about testing microservices. So I really think it's an area that we can kind of improve upon and look more into. So what's out of scope for this presentation? I do only have 50 minutes, and I feel like testing, to completely test an application, you could kind of go on for a long time. So I'm not going to cover any sort of performance testing or testing for scalability or security testing or monitoring. I'm kind of looking at what we as developers looked at as we were writing our application and how we were kind of going along. We used test-driven development, so it was kind of the tests that we had to write in order to write our application. So that's kind of what I'm going to cover. So before we get into talking about the actual testing, I'll do a quick overview of what are microservices and the kind of key points that maybe you can take away from all your many talks over the last day or so. So a microservice is an application that is then split down into different services, and each service has to have a specific role or function, and that's how you work out how to split it down. The services communicate over language-agnostic protocol, for example, REST, or you could use other language-agnostic protocols such as WebSockets or other messaging services. And the nice thing about this is that then, because it's language-agnostic, you can write your different services in different languages. And I guess for us, looking at what we're creating, that was something that was going to be really valuable, because if a different team outside of Liberty wants to come along and write something for us, then they can do it in whatever language they want to. They don't have to stick to Java. And finally, the service should be independently deployable. So whereas with our monolithic application, everything's deployed on the one server in the one Docker file or whatever, now you have the pieces all deployed separately. And there are some great things that come out of moving to microservices. You might want to move to get more rapid delivery, because now that you can push the different pieces independently, you can iterate through the pieces separately. So if one team finishes something, they don't have to wait for everyone else to be finished before you get the new code out. To better use scaling resources. So again, because it's broken down, you can scale one piece rather than scaling the whole application, and that can save you a lot of resource. And also to move pieces to the cloud, which is kind of an angle that perhaps isn't touched on as much, but it might be that actually you want to manage your application slightly differently like we did, or there's a piece that you don't really want to have to deploy on your own resources and you want someone else to put it on the cloud somewhere. So that's an option, that's a good reason to move to microservices too. But there are some considerations. It's not a silver bullet, it's not going to solve all your problems straight away necessarily. Because you have all of these new pieces, they may be simple in themselves, but you have increased deployment overhead because now you have to deploy 4 or 5 or 6 pieces. You have increased complexity because now you have all of the plumbing between all your pieces. So although the individual services could be really simple, there's complexity in the way they connect together. And we'll find that actually some of the testing is really focusing on that change. And also, I felt I couldn't not mention this, but your testing strategy might have to change. So that's another piece that perhaps you hadn't really considered before, that actually you might need to go back and rethink some of the ways you do testing and the order in which you test in your build pipeline, for example. So now that I've given you a quick overview of microservices, we can go straight into looking at our sample microservice in a bit more detail so that we can look at the testing strategies in comparison. So this is the sample microservice anatomy that I've kind of shown. The dotted grey line around the outside is the whole application. And then we have blue boxes, which I've put to indicate the different services. So you can see there we have the zip service that I mentioned earlier, and that's the service that my team would own, for example. And then we have some amount of text services. In the current version of the Liberty Starter on Bluemix, I think there's 6. I've only put 3 here, because what we're going to focus on today is the internals of the zip service. Each of the different services would probably have quite similar internals, and you would have to test them all in a similar way. So for today, I'll just focus on the zip service, but keep in mind that you would still have to test all your other services in the same way. So this is sort of a deeper dive into how our anatomy looks. It is perhaps a bit simplified, but we've got, at the top, we've got where the user accesses the service through an API gateway. So that would be sort of where the front end lives. We've got some domain logic, which is what's actually building up our zip file. A data connector, which calls out to a database. And in this case, the database is holding a list of the services that are available. So this could be your service registry. For our application at the moment, we have a list in a database that we sort of update when the services come and go. And the service connector, which is the piece that's calling out to the individual tech services. And hopefully you'll see why I've broken it down in this way as we go through the different testing strategies. So on to the testing strategies. I'm going to cover 5 different strategies. And some of these names are probably familiar to you if you've been testing monolithic applications. But hopefully by the end of this talk, you'll kind of see where each of them could be thought of slightly differently in the microservice environment and where you might have to make a few tweaks. So we'll start with unit testing. So typically, unit testing is testing a small piece of behavior, usually at the class level, but if there's several classes that are closely linked, it could be slightly wider. And if you're using test-driven development like we were, then that drives your implementation, which can be quite a useful tool for making sure you write your application in a nice, organized way. And there are 2 types that I'm going to highlight of sort of methods to unit test, and that's black box testing or test doubles. When I did a practice of this presentation, the name test doubles kind of raised a few questions, and this is sort of a generic term for any object that you create just for the test run and you don't put it into production. Often they're called mocks, so a mock is a type of test double. So black box testing. This is where you would use the actual object and treat the unit as a black box. So you call into the unit and see what your response is, and you don't put any sort of framework around it. It's useful for testing domain logic that's highly state-based, because if you have a lot of moving parts around your unit, then perhaps putting in extra framework or test doubles will not give you consistent results and perhaps give you a false view of how your system is doing. The example in our application where we could use this is to test the sort of base project construction. And what I mean by this is that when we build up our zip file, we have to start off with the pieces that are common across everything. So no matter which technology you select, we still want to give you a Maven build script that gives you, compilation of your code and gives you testing and everything. And there's certain testing dependencies as well. Like we might say, okay, we think you always need some form of test dependency, so have JUnit. So that's kind of the piece in here that we would have for that. And then the second piece, which is kind of what we use more, and you could use both of these or just one or the other, it's kind of up to you, but we use test doubles most, which was to create a test double to isolate your individual unit. And this is useful if you've got a routing layer and you're just looking at, are the requests being routed to the right places? Because you can just create a test double that reflects what you expect to happen. And for gateway and repository testing, if you're checking that the messages are really being passed around in the right way. And I've got an example here of how we did this. So this is a stub service connector. And so it's not a mock, it's a stub, so it just implements a couple of different classes. So you'll see up here we have just 2 methods that we've kind of made versions of. What they're doing is just passing back sort of pre-canned responses. It's not in the actual production system. The service connector would call out to our services and go get some information. In this case, we're just returning something pre-configured that is kind of a stub of what we would actually have. And this is one of our example test classes. So this is just using JUnit. So in Maven, we just declared JUnit as one of our dependencies. And here you can see that we're testing a class called the dependency handler. And all the dependency handler is doing is grabbing dependencies, Maven dependencies, and it's kind of storing them in a certain way to pass on to another piece, which is building up our zip file. And the reason that in this case stubs are very useful is because we can create a stub service connector and pass that to the dependency handler. And we've set it up so that the dependency handler, the only thing it calls that then calls externally is our service connector. So once we have a stub version of it, we can then completely unit test our dependency handler without worrying about other state changes affecting what's going on, because we know all the calls come to our stub service connector. So that's just a quick example for you. So far, unit testing perhaps looking pretty similar to how you would do it in a monolithic application. So what are the things to consider when you're in a microservice application? Well, although it's not true that microservices have to be small, it certainly is true that people, when they move to microservices, often find that their services can be quite small, and it depends on the function involved, but you could find that you have a lot of very small services, and actually find that your complexity moves from being in your service to in the plumbing. The actual units could be doing very little, and the real complexity is in how you pass between the different pieces. And when this is the case, you have to kind of look back and think about, are my unit tests really giving me that much? You always want perhaps some unit tests, but it might be that unit testing isn't the way to go if your individual units aren't doing any complex logic at all. And you also find that because you're then passing lots of pieces around, whereas in my example a minute ago I said, we were just calling out to one different class, so we only had to have one stub. If it's calling out all over the place, then you have to create many different mocks, and then if someone comes along and changes something, you have to go around and update them all, and then that kind of leaves you open to people being perhaps a bit lazy and not updating them quite the way they should, and then you end up with tests that aren't really testing what you thought they were. So there's definitely a trade-off between the time to maintain the framework and the different test doubles for your unit tests and the usefulness that you're getting from your test suite. So you should really look at making it small and focused as possible. And actually, in some cases, perhaps unit tests aren't the most useful, but you should instead look at component testing, which I will cover next. So a component test is, again, perhaps a phrase that you've heard before. It tests a portion of the system, and this component should be a replaceable piece of the system. So in a microservice world, this leads quite naturally to a component being a service, and you can just have a one-to-one mapping between your components and your services. And I'm going to cover two options for testing these components. The first is altering the internals of your component or your service, and the second is creating a test service. So altering the internals. By this I mean creating an internal interface inside your unit that you hit during testing but not in production. So you don't touch the network in this case, and you instead route your calls into this interface. That means you don't have to make any calls out to anywhere else, and you really do test your one little component. This is really good because it gives you fast execution, and you're not having to start up a server, so you can get really quick responses to find out, did the change I just made break anything? Did it fix what I was trying to fix? It gives you a fast turnover. But there are things to consider. It does mean you're then mixing your application code and your test code in together, and you perhaps have to think carefully about how you then push that into production to make sure in production you're hitting the right classes. But also, it could mean that you miss things. So if you've got a class that you're calling into only in the test case, then there's probably some other class that you're not calling in your test case. So what happens in production? Is it working? That's kind of the two things you have to consider. So what we did for our system, and what worked very well given the structure that we have, is to have a test service. So here I am just talking about me personally testing my zip service. I'm not worrying too much about the people who own the different tech services. in my opinion, they should test their own services. So for my particular service, I can say, well, I know that each of the services I'm going to call out to will look roughly the same. We're going to ask them for similar things, and they're going to return us broadly similar things. So actually creating a test service that does everything that we might expect from someone else is a really good option. And it means that the complexity is then contained within the test service rather than in your application, and it kind of gives you that nice separation. It also thoroughly tests your network calls. So the way we set it up in our application is we have our test service start up, and we access it via REST requests in exactly the same way that we would all of our other services. We don't call it directly, we just go via REST. So we really are testing the network calls. The downside is that obviously you're now starting up a server to run these tests. You don't get that fast feedback. There's the increased execution time. So how did we do this in our application? So I mentioned earlier that the payload you get from the Liberty Starter gives you Maven build code. For our particular application, we're actually building it using Gradle. There was a combination of different people in the teams having different opinions, and the fact that we thought it'd be nice to kind of learn both. So we have Gradle for our actual application. And what you can do in Gradle is write your own Groovy files that then create sort of custom tasks. And in Liberty, you can create a server.env file, which is just a file that contains environment variables for your server. So what we do is we just have a custom Gradle task that, if a property is set, it creates the server.env file with the properties you've specified. So the top piece here is our Groovy file, and then the bottom piece is a line in a Gradle.build file. So that's our main build file that says, I want you to put the location here. And what we do is we run add server env just before we run the tests, and then we run remove server env, which I haven't shown here, after we've run the tests. So then by the time it gets to packaging our application, the server.env file is no longer there, and we don't worry about packaging environment variables that will cause errors. And then in the production, we can just set up a new environment variable that tells us where our database actually lives and where you should go to find the services that are available. So I'm now going to move on to talk about contract testing. So far with unit and component testing, I would say these are things you've probably done quite a bit before in monolithic applications, whereas contract testing is perhaps something that you wouldn't have had to consider as much before. So here, by contract, I'm defining this to be an agreed set of input and output attributes. And contract tests simply test that the inputs and outputs have those particular attributes. You're not checking for behavior that happens once you get the attributes or anything. It's just, are you expecting the right attributes, and are you giving out the ones you say you're going to give out? And it's testing the boundaries between your different application and your external services. So in this diagram, I have 4 little red circles for where the contract tests would apply. If I was owning the zip service and just worrying about testing the zip service by itself, then I would just own that one set of contract tests. And the aim would be that if you have an organization where different teams own different services, you would each own your own contract tests and would be in charge of keeping them up to date. But everybody owning their own contract tests doesn't really get you the whole way there, because the contracts have to be compatible with each other. There's no good me as the zip service saying, well, I don't accept that input, and someone else being like, but you need to, otherwise it won't work. So you've got to have some communication there. And this is where I think the way you structure your organization, if you structure it to match up with the microservices approach, so you have different teams who own the different services, then you can really use contract tests to help with the way your organization communicates. So as the team who owns the zip service, I would go to each of the different services that I know I call out to and say, please give me your contract tests. So I get a copy of each of them and line them all up next to each other. And from that, I can get a picture of what my service contract should be. So when I look at all of the individual contract tests, my contract test should match up in some way, and I should be able to see the good connection between them. And the reason this is even more powerful is because then if you need to make changes, if a new service comes along and says, well, I want to add this attribute or something along those lines, then they can write their service, write their contract tests, and then pass them over to my team. And we can use those contract tests to update our service contract and update our application. So this means that not only are you thoroughly testing your applications, but you're actually making use of the tests that you've written to make sure that everyone is clear on who communicates with who and what they expect from each other. Because I think it's fair to say that if you have two people in a room together having a discussion, often if they leave, they might have slightly different views on what was decided, whereas if you have it in a set of tests, it's very concrete. So I'm now going to move on to covering integration tests. So integration testing is a phrase that I think in monolithic application can apply to all sorts of different types of testing. And in this particular context with microservices, I'm going to be very specific about what I mean by integration testing. So by integration testing, I mean tests that test the interactions between the different components, and they're testing for success and that you have error paths in place. So they're not really testing for behavior. We saw previously that you could have component tests that were some form of integration test with starting up the server, but in this case, it's just the basic, if I make a request, is it successful? And if I get a timeout, am I handling that correctly? And in a microservice environment, these are the reactions with other services, the interactions, sorry, with other services and with data stores. So in our specific application, you can see here it's all of the interactions with the different services. So although I've drawn one box, you would kind of have one for each of the interactions. And then your interactions with the service list. So that's from the data connector to the service list. But there are some things to consider when putting in these integration tests, beyond sort of the things you might have had to consider for monolithic applications. Because they're calling across the wire, you can have connection failures that could cause false errors and could cause your tests to be very unstable. So because we've already had the contract test where we're testing for the right attributes and we've got our component tests that check for the behavior and things, in some ways, you need the integration tests, but perhaps you don't need them as close to the developer as you had previously, and you could consider moving these tests to the build pipeline. And what I mean by this is, I've seen quite a few teams where they have the developer writes some code, and they run unit tests, they run component tests, and they run their contract tests. But then as soon as you want to run your integration tests, you need to connect up to all the other services. So actually, at that point, you can push your application up to a staging environment where everyone else's staging services live, and then you can run your integration tests. And that means if the developer wants to check a quick fix or something that they don't think is going to affect everyone else, they can do the change, check that they fix whatever they fixed, and then push up to staging. And then at that point, they run the integration tests. And if those fail, then maybe they have to go back and think again. But it means for those quick changes, you're not having to wait to build all the other services, for example, in order to run your integration tests. So having that staging environment and pushing running of the integration tests a little bit later in your build pipeline can be a really useful tool to use. So the last strategy that I'm going to cover is end-to-end testing. End-to-end testing is something that, having spoken to a few people about how they test their microservice, I think quite a few people kind of said, oh, we're not going to worry too much about that because, you know, if I have to stand up all of my services and run a full end-to-end test, it's probably going to fall over in some way. It's not going to be that stable, and maybe I won't worry too much about it. And although I think perhaps you don't want loads and loads of end-to-end tests, you do still need end-to-end tests to make sure that your system meets any external requirements. So these could be a user story or a particular path through your application that you know is quite common. And setting up an end-to-end test really is sort of a sanity check that all of your other tests haven't missed anything. There isn't some strange behavior between two different services that causes some other strange thing to happen. It's really checking that if you stand everything up, it does kind of work as you expected it to. And I think the point where you perhaps really can't forget about end-to-end tests and really have to make sure you put them in and make sure they're really effective is if you've got a stateful system. If there's a lot of state involved in the sort of behavior and calculations that's going on in your application, then there's a much higher chance that your test doubles or your test service or the way you've done your black box testing has missed something in this. And actually, when you stand everything up together, something about the state doesn't follow through quite properly. So I think that's the point where you really do need to look carefully at how you're doing your end-to-end testing. And the other thing to note with this, which I think, again, is an area that perhaps can be kind of left till later for a lot of people, is the UI testing, which is definitely something that shouldn't be left till later. You should be running UI tests and automatic UI tests, because yes, you could go and manually look at your UI and see if everything works, but the more complicated your UI, the more time that's going to take for you to click every button and see if it goes where you expected. So you can use tools like Selenium or other UI tools to just hit the UI and see what happens. And in our particular application, the sort of workflow that we would have for our end-to-end tests would be for something like Selenium to come to the page, select every technology type, for example, click the download button, get the downloaded zip, and then perhaps even go as far as building the zip and running Maven install. And if everything passes, then we're happy, our end-to-end test works. So I've kind of covered the 5 different strategies now. So I'll give you a quick recap. So far, we've got unit testing, which tests the behavior of the individual pieces within your services. We have component testing, which covers a specific service. And we have contract testing, which tests the contract that you've defined to call out to other services. And these first 3, each team that owns that particular service would own those tests. Then you have integration testing, where you're testing the communication, is it success or failure, between your service and other services, external services, or data stores. And these tests would sort of have to be owned at a more team-wide level if you have your different teams owning your different services. And the final one is the end-to-end testing, which is a full flow through your entire application to make sure that you have picked up the edge cases and the points where something could have gone wrong that you haven't caught earlier. So I'm going to move on to monolithic to microservice, unless anybody has any questions at this point. I will open it to questions at the end as well. Okay, we'll move swiftly on. So now that I've covered a set of sort of general strategies for testing microservices and how you would do it slightly differently from in the monolithic world, I'm now going to talk about what we found moving from a monolithic application through to a microservice application. So these are some things that we found and that we feel like you should consider as you're making the move from monolithic applications to microservice applications. The first thing is to add tests for current function and fix flaws later. So the reason that I suggest this is previously in our team, we've been looking at doing an evolution of an example which is called Plants by WebSphere, which is an application that was built quite a long time ago to do an example of how you would do Java EE applications. And as we were doing our move to microservices, there were quite a few things that we thought, oh, this doesn't really work how perhaps it would be nice for it to work, or maybe we should just change this thing. And that's quite a dangerous thing to think up as you move through to microservices. And the reason for that is even if you have fully tested your application, you may find that changing things partway through your evolution can cause unwanted and unexpected problems elsewhere. So I think it's important to make sure before you do your evolution that you have a good set of tests. But if you do have to write the tests because perhaps you weren't as good at writing the tests as you want to be now, maybe you haven't got the full coverage you were looking for, I think the key thing is to add tests for the current function of your application. So from the 5 that we covered, perhaps that would really be the end-to-end tests. To an external user, what does the application do? Rather than the specifics of how it works internally, because ultimately, while you move to microservices, you are going to find that those individual pieces and how it works is going to change. The other thing to consider is that as your monolith changes, you will have to change your tests. And hopefully, from the different strategies I've talked about, you might get an idea of what changes you'll have to make and how you might have to rethink how you're doing your testing. But just be aware that when you change your monolith, you will have to update your tests because there will be certain tests that are very specific to that specific way you were doing it before. And this is where I'm going to give a little plug for test-driven development, because I think if you're writing your new microservice application, then actually writing new tests to replace the old ones might be quite a nice way to do it. You can write your test, make sure that it currently fails, and then write your new implementation or your new service or something and see that your tests now pass. And now I'm just going to call out a few sort of useful things to think about using as you're doing your evolution story in terms of testing. So the first one's not necessarily specific to testing, but it will enable you to test more easily, which is to have quite a small set of classes that call externally to your service. So in our diagram, I showed you that we have our service connector that calls out to all the different services. And that's worked really well for us because we can just replace the one class and use that stub class that I showed earlier to test all our different units within our zip service. So perhaps keeping that in mind and not going too crazy too quickly and not getting too small too quickly will allow you to have better unit tests and have unit testing that doesn't take up too much of your time, but gives you the coverage that you really want. The other thing to use, as I just said, is mocking and having test doubles. So that's kind of combined with my first point. And then the final one is having a test service for component testing. And the reason I'm pulling this one out is because it's something that I hadn't really seen before. Like, the idea of creating a whole new service just as a test piece is perhaps a bit of a strange notion, but because your services are smaller than your monolith would have been, it does kind of make sense. And I think you have to bear in mind the context, and for us, it made complete sense, but perhaps when we go to test our individual technology services, having a test service won't make as much sense, but it's something to consider. So, on to my conclusion. So I would say this is still very much a developing area. As I said, there's plenty of talks at this conference about microservices, but I'm pretty sure I'm the only person talking about testing microservices. So I definitely think it's an area that we need to look into more, and when you're writing your microservices, test them as you go along, and don't leave it as something that you think about later. Because in some ways, by writing a really good set of tests, you can be even more sure that your application is doing exactly what you expected it to do, and that when it fails or when you do something that breaks someone else, you'll know about it. And particularly when we're moving to organizations that are structured around the different services, you can really use the way you test to enable you to have better communication between the different parts of your organization and the different owners of the different services. As I said in my previous slide, I think having a dummy service or a test service is a really useful tool, but you should really adapt your tests to suit the development and deployment process. So at each stage of the different testing strategies, I talked about a couple of different options, and it's definitely true that you could just pick one of the two options, or you could do both, or it's kind of up to you, and it really depends on what your application is doing. Oh, so that's kind of the end of my talk. I do have some slides about my thoughts on Gradle or Maven if anyone wants to come and talk to me afterwards. And in terms of sort of extra reading, there's a really good slide set from Martin Fowler, which is the link at the top there, which I would definitely recommend you go away and read. And if you want to learn about more microservices in general, then if you go to wasdev.net, which is the WebSphere Liberty sort of developer site where we have a lot of documentation and you can download Liberty and stuff. If you go to docs microservices, you'll find some more articles by me about 12-factor apps and some other things around microservices, and some other documents and articles from my other colleagues about logging and other things around microservices. And if you want to check out the Liberty Starter, feel free. It's at ibm.biz/Liberty Starter. So thank you very much.
Any questions?
What tools do you use for contract testing, or how to do this?
So for our contract tests, we're using JUnit, and we're actually starting up a Liberty server in order to run our contract tests and accessing them via REST. The other sort of useful tool that we're hoping to start using, but we're not currently, is using our Quillian. So if you find that there's certain pieces in your application that if you don't start them up in quite the right way, the server, it doesn't run them, and if you have CDI and things like that, if you use our Quillian, then you can have all the pieces start up correctly. But for us, we're just setting up REST requests into our APIs and starting up a Liberty server. Because it's worth noting that the WebSphere Liberty is very quick to start up and shut down. So we found that actually, like I said earlier, for our component tests, we're using a test service because we found that actually starting up Liberty didn't cost us that much. So.
When doing the contract testing, you pointed out that you also tested the outbound contract from the zip service. Mm-hmm. How do you do that? Because then it's not about calling a service; it's about testing the callee.
Yeah, so it's about checking that your REST endpoints are accepting the calls that you expect. So if you make some calls in that have attributes that shouldn't be allowed, you need to check that your REST client is kind of handling that. So you can kind of still test it in that way. But I think the key thing is that you will find you'll have more tests of the outgoing than incoming, but then when you combine that with the other people's contract tests, then that's kind of the comparison of those two contract tests is kind of the way that you can make sure that you really are testing effectively, because as long as your incoming calls accept the ones that you know are coming in, does that make sense? Then it kind of covers. So I think in answer to your question, it is more difficult to test that, and I don't think you can test it as effectively. But the key thing is to make sure you combine your contract tests with someone else's contract tests, and you can't write your contract tests completely separately from the other team. There has to be some communication, because otherwise it just won't work.
Okay.
Have you been involved in testing the deployment of microservices?
So at this point, no, I haven't really looked into how you test your deployment. So for our application at the moment, after we deploy it, we run some tests and we've set up some monitoring. But it's certainly an area that I want to look into further, because I haven't found that much information about sort of good ways to do it. So at the moment, as I say, we deploy our application and then we do a quick sort of, is it responding test, but nothing more detailed than that. And certainly an area that I want to look into more.
Thank you.
If you're going from monolithic architecture to microservice architecture, and you decide to start off with building lots of tests, it seems to me that the unit tests and the end-to-end tests should be more or less intact, but the middle tests need to change, or is it even meaningful to implement such tests on the monolith?
So you're kind of asking if my monolithic application, is there much point in introducing tests that aren't really effectively testing the monolith just because we know later we'll need them? Yeah. So I would say that's a very valid point. I think the tests that you would look to add if you don't have any tests on your monolithic application is the sort of end-to-end testing, and perhaps you wouldn't look at the specific unit tests. But if you don't have any tests on your monolith, then you certainly should, because it will help you a lot in knowing when you have got something right while you're doing your evolution. In terms of the new tests that you write on top of the ones you already have, I think focusing on writing the tests as you write your services is kind of the key point. So you don't need to, I'm not saying you should write a test that you then don't have any implementation for yet. The idea would be you would write, say, I'm going to create this service, and as you create your service, write your tests for your service. And then at some point, you will need to connect your service into your monolithic application. So the approach we kind of took was working out what service we were going to create, creating it, and then changing the monolith to then call out to that service. So the unit tests and the component tests and things would be testing the microservice or the individual service. So I think the unit tests and component tests you would have on the monolith, you would want to leave until later, until you have removed all of the sort of pieces that have now been extracted out, and then you can then implement meaningful unit and component tests. I think that's kind of the workflow that you'd want to follow.
Hi. Are consumer-driven testing equivalent to the term contract testing that you had used?
Consumer-driven testing?
Yeah, and tools like Pack2.
So I guess the key difference would be that by consumer-driven testing, do you mean from the user or from
No, it's the tool Pack2 basically records the outbound requests that you're going to do, and then you give them to the service provider, and then they record your requests and their responses, and you can then go around the circle.
Yeah, so I think that would be the equivalent of testing, of the contract testing. The key thing is to make sure that those specific tests aren't checking for behavior, it is just the call. But yeah, I think the consumer testing would be the equivalent of contract testing.
Any more questions? Oh, I think that's fine then. Thank you very much.
Thank you very much, everyone.